Assalamu alaikum. Respected Aiman Education Welfare Society founders, executive members, and all other management people, respected principal, principal of Aiman Women's Arts and Science College, and head of the Department of Mathematics, all other faculty members, participants, researchers, and student friends. Once again, good morning to one and all person here. Due to unavoidable circumference, now you are seeing the recorded version. With this introduction, can I enter to the presentation? I can share my screen and then continue my presentation. I think now screen is visible to all of you. Yes, again welcome you all to the technical session. Today we are in the very good situation, international conference on recent trends in mathematics and its application. Title of the today talk, Recent Development in Cancer Mathematical Modeling. I am Dr. Fazlul Kareem, Assistant Professor, Department of Mathematics, University of Technology and Applied Science, Al Musanna, Sultanate of Oman. Title of the today's talk, Recent Development in Cancer Mathematical Models. Before going to the technical session, I want to tell about few things. When I presented today, this is not finding for me only. This is the collective information from the various people. There are more intellectual. They are working in this field. I'm the very small person in that research field. Here I am presenting the collective information from the intellectual people. To my level best, can I make it? This presentation is interesting to all. And in between the presentation, I can play three videos about the related to the presentation. Most probably make it fine tune and compress and short and sweet. I will complete the presentation. Can you begin these words to the technical session? This is my great honor to respected. This is my time to honor to respected my research supervisor, Dr. P. S. Kuduman, Professor in Department of Mathematics and Actuarial Science, B.S. Abdur Rahman, Crescent Institute of Science and Technology, Chennai. And my honor to respectable my professor and mentor, Dr. R. Jagir Hussain, Associate Professor, Department of Mathematics, Jamal Muhammad College, Tiruchi. And this is my time to honor my advisor, Dr. Sadaqatullah, Associate Professor, Model University, Dubai, UAE. With these people, I'll stand here. Can I continue my presentation? Now we enter into the technical part. Before going to the technical part, I want to mention few words from the mathematical intellectuals. George Box is one famous mathematician. He told about all models are wrong, but some models are useful. Here, George Box mentioned about the mathematical model. Many people developing a mathematical model, all models are wrong, but some models are useful. He mentioned that. That means all models are not wrong. Some models are more efficient and useful. Some models are not that much. That point George Box mentioned here. And then Max Gunberger is another mathematician. Tell about few words. Computational results are believed by no one except for the person who wrote the code. And experimental results are believed by everyone except the person who ran the experiment. There are two different things are there. One is for computational results, another one is for experimental results. When we computational results give to the research society and or to the any people, many people are believed. But experimental results We know when we ran the experiment, what it happened. That's we know the real situation when run the experiment that mentioned by the Max Gunberger. And then all of you know about Albert Einstein, the famous scientist. He invented for the relativity theory. E is equal to mc square. One time, Albert Einstein given the talk about the relativity theory. In the questionnaire session, the people asking the question, Mr. Einstein, you developed the E is equal to mc square. We know, we believe that EC square E is equal to mc square concept fully understand by you and God only. Like that, one gentleman asked the question to Einstein. Einstein, he is not a God believer. Einstein, he is not a God believer. He is a agnostic. He don't have an opinion about the God. So he immediately say the answer. I don't know if God knowing this relativity theory, but I don't know clearly. E is equal to mc square invented by Einstein itself. But even though the gentleman, the very good scientist, tell about I don't know exactly what it means. Then I want to mention the another professor, Kip S. Throne. He is the professor given the introduction to Stephen Hawking book. The you know about the 21st century scientist, very good person, Stephen Hawking. He wrote a book, Brief Answers for Big Question. That is the final book of Stephen Hawking. In that book, Kip S. Throne given the introduction about the Stephen Hawking. I have shied away from the big question. I don't have enough skill, wisdom, self-confidence to tackle them. Keep yes throne. Tell about Stephen Hawking. Stephen Hawking given the clear answer for the big question. The questions are very big. He given the simple and acceptable logical answer. About Stephen Hawking, Professor Throne says that I have shied away from the big question. I don't have enough skill, wisdom, and self confidence to take these questions. I hope find this answer as stimulating and insightful as do you also enjoy it like that he complete the introduction. The same words I can take it as this topic, today's topic is a very interesting one and very technically and more effective topic. I don't have that much of wisdom and self-confidence. I can take in the words from S. Throne. When I start the presentation, I told that this is not my finding. I'm also a very small person in that group. This is the collective information. So I can take the quotes also from the Professor Throne. I don't have wisdom, self-confidence, but even though to my level of best, I can explain to you all and make it to the interesting one for this 1 hour session. And also we are in the recording version, so there is no chance for answering your questions. We wind up with the presentation. Then I will display my name and note it my mail ID. If you have any useful question or comments, you can send us a mail. Do not expect immediate reply. If possible, can I reply as a short of time? As early as possible, I can explain. So with these words, I enter into the technical session. Can I explain by word? The first one in this session, we will talk about the recent development in the cancer modeling. In that cancer modeling area, there are two words familiarly we use. One is called tumor, another one is called cancer. These two words understand most probably in different manner, but it is sometimes same, sometimes may not be same. What we technically call it as a tumor, it's an abnormal growth in the human body or any other living particle. If we know in general thing, if we have extra normal growth in our body, if we have pain in that, then we go for the treatment. If we don't have pain, we don't care that much. But the medical science says if you have any extra normal growth in your body, there is no pain, you can take and care much more for that. The extra normal growth, it is called as a tumor. In that extra normal growth, there is a cell for cancer cell. The cancer cell is muted, started, then within a fraction of second, one cell can be converted into millions of trillions of times. We cannot count it easily. If the cells are muted, then the abnormal growth can be called it as a cancer. So all the abnormal growth need not be a cancer. Sometimes it may cancer, sometimes it may not be the extra normal growth due to the various reasons. So technically both words are different. For our understanding purpose, I can say like that tumor is the initial stage, cancer is the developed stage. This is called benign, this is called malignant. They are using the technical word. So when you have the abnormal growth in our body or any other living particle, it can be called it as a tumor. The cells are muted, the mutation is started, then it can be called it as a cancer. In our presentation, always we are mentioned tumor, tumor, tumor only because we can deal the extra normal growth. It may cancer, it may not be cancer also. We cannot assure it. So hereafter we always mention sometimes tumor. If it is the cell is muted, we may confirm. Then we may use the word cancer also. So we should understand the difference between these two words. Now the questions will come. The tumor or cancer is related to the medical field. How mathematical people connected to this? That big question I can take it as initially. I'm sure about it. This is purely related to the medical field, but it can be connected with mathematical 100%. I can assure it. I can take one good example when we are teaching to the undergraduate or postgraduate students, BSc Maths or MSc Maths student in the math class. When we solve the something application problem, or many of the time the student asks question, teacher, where it can be applied, where it can be applied, why we want to study these many things we may ask to our teachers. Sometimes the teacher answering the question, sometimes you came to know when you are enter into the research field like that, you came to apply, then you came to know the clear picture like that. Our teachers are telling that same answer. I'm also telling it is possible to apply all the mathematical concept with effective manner. Then I can start with one simple, easiest one. Everyone know about this. When we study differential equation from school days onwards, as we know, the first order differential equation or second order differential equation, there are two parts. One is the left hand side, another one is the right hand side. If the right hand side is zero, then we write the complementary function based on the auxiliary equation. For example, I can take as a second order differential equation, then we write the auxiliary equation am power 2 plus bm plus c is equal to 0. It is a second order equation, it's a quadratic equation, then we have the two roots. There are three possible ways of the roots available. One is both roots are equal, both roots are unequal, or it may be the imaginary. Based on the auxiliary equation, we may write the complementary function as we understand. Then if it is there is a right hand side part, then we find the particular integral. The right hand side part, there are the various possible cases there. It may be the exponential, or it may be the algebraic, or it may be the trigonometric, or combination of all. And we find the different uh, particular integral. Then finally we wrote the general solution y is equal to complementary function plus particular integral. If we have the initial condition, then we apply the initial condition, we can get the constant value, and finally we can give the general solution. This is when we studied the undergraduate or postgraduate or allied mathematics, we studied about the differential equation. It made in the second order. That differential equation we can take a very big role in the cancer modeling. Can be written as dx by dt. What does mean with respect to time, the changes happening in the x? Here we want to calculate the rate of changing with respect to the time. What is the change happen in the abnormal growth? We can take it as a directly ordinary differential equation. For the peculiar situation, we may take partial differential equation, delay differential equation, fractional differential equation. There are more parts are there. Based on the ordinary differential equation, it will travel to path. Using the differential equation, we can find out the rate of that is we can find out the growth rate easily. Then based on the situation, we can find the sometimes one equation, sometimes two equations, sometimes system of equation. And as you know about the general thing, and the tumor growth, it is not same for one. That is a peculiar critical situation. For example, I can take one simple example. As a person, a male person around 35 years age, uh, that male person having extra normal growth in the right finger, right leg or left leg finger, any finger, one finger, he has a extra normal growth. We want to construct the mathematical model for the extra normal growth in the detail about the person 35 years age old male person. Based on the person, we may consider many parameters are there. It cannot be same to the same age, same sex to the another person. Due to the various reason, it will differ to act differently, act as the extra normal growth, due to the hereditary problem, due to the food habits, due to the climate, due to the genetical problem. There are more reasons are there that the extra normal growth will act in different manner. So we cannot make it as a generalized one. As a 35 years old men having the extra normal growth in some part of body, the same age, same sex, another extra normal growth is there. We cannot equate the both situation. It is entirely different. It will act is different. This is the challenging task in this field. We cannot make it as a general. Each person, it will act different manner. Some of the common terms are, some of the common futures are, common situations are there, but it not be equal to anyone. If it is sex are different, male and female, age is different, hereditary is different, the domain is different, living part is different, food habits is different, then there are the different actions are there in the extra normal growth. So this is the challenging task. We cannot make it a generalized one. We can deal individual person for the individual situation. As you know about the extra normal growth available in the finger, due to the practitioner, medical practitioner given the guidelines based on the tumor, based on the situation. If it is in the finger, we can remove the finger based on the condition. If it is the extra normal growth available in our throat, how can we remove the throat? If we remove the throat, how can we live? If the extra normal growth available in our more moving urinary path or motion path or inside our stomach, it is a very tedious job. It is difficult. So we want to treat properly, and we want to identify at the earliest. We want to given the proper treatment. There are more situations it will come after analyzing the model. So we construct the mathematical model is a effective one. If we frame the effective mathematical model, then it will become a meaningful, many things it will come. So we should, I can say in simple words, the differential equation is a play a vital role in this area. Then the next question will come, can math cure cancer? Throughout the globally, they are fighting with the cancer with the help of mathematics and medical sciences. This fighting is going on. This is not a true or false question. I cannot say it is true, it is false. The fighting is going on. Somehow we win the fighting. Sometimes we may failure also, but the process is continue. Medical world accept this research in this current era? Yes, absolutely, they will accept, but with a certain stage. As you know, based on our guidance, based on our suggestion, they cannot given the treatment to the human. It may failure mean then it will become an offense. Something make it a danger. The person also may die. So when we start the research with the mice and then we go to the monkey, then there is a next one. Like that, we want to travel stage by stage, but we usually we done the research in the theoretical part, and then we done the experimental part also successful with less error, then it will be acceptable by the research, acceptable by the medical people. This is going on, this is a continuous process. If accept mean what is the output? The answer already I told. This fighting is going on. We cannot assure we will deal directly. Something we guidance as per our assumption, as per our conclusion. We given the guidance to the practitioner. They will take it to the account. Sometimes they will take it 100%. Sometimes they will take it 50% based on our results weightage. They will take it, but they will consider. I'm sure. How the mathematician connect to this medical field? Already I told there is a connection between, with the simple example, differential equation. I told one technical word. There are more mathematical concepts which involves here. So directly there is a possible chance to connect the mathematical field. And then the simple question will come, sir, you are saying very interesting one, how to learn this field. That's very simple. Nowadays, no need to travel to anywhere. We learn, we sit in our room, we sit in our office in front of the system, can learn more. This is the social media world, the world connected with the single point. Everything is connected. It is possible. If we have enough time, if we have patience, carefully listen everything, then we can easily learn. And then I want to mention about especially this topic. This is a multidisciplinary research. This topic will involve mathematics and physics and biology and medical, everything which involves this is a fully collaborated work. So this is the fully application part. Everything is involving here. There are various parts of involving here. Now I want to tell about the next one, the number of publication about the mathematical modeling of cancer growth. It's going to experimental rate according to the PubMed records. Those who are involving the result, they know about the PubMed record that is related to the American Mathematical Society, background of the American Mathematical Society. The number of publication, it is increasing in terms of exponential rate. Not only the number of publication, that effectiveness also it is increased. That is started by the mathematics, finally they come and stand in oncology. That is called mathematical oncology, means especially dealing about the tumor and cancer. Technical word they call it as, that department they call it as mathematical oncology, biomathematical, in simple words we may say. This is the simple graph, the number of publication as per the PubMed records in 1960, one or two papers in 2020, as you know, more than 200 publication, especially in the modeling of mathematical modeling of cancer. This is the simple identification, how much this field is increasing. The rate of increasing is exponential, it is increasing. Now I can take the next one. There are two concepts are there. One is called bottom up approach. Another one is called top down approach. What does mean the bottom up approach? We frame the mathematical model with some conditions, then we analyze the mathematical model, then finally we get the output from the model. That is called bottom up approach. That means we started from step one, then we construct the model, then we get the results, and then we can proceed. Top driven model, already they have mathematical model for the peculiar situation. We take the mathematical model and then we give the meaningful disturbance, something parameter added, something parameter removed with the proper reason. As we know, when we construct the mathematical model, there are 7 or 6 parameters are there. If I remove the one parameter, then I want to say the proper justification why I remove the parameter. If I add one parameter in there, then I want to tell about what is the parameter, I want to add with the justification. Like the bottom up approach, mean we develop a mathematical model, then dealing with the proper meaning. Top drive method model means already somebody developed the model, then we can take the model, we interrupt them, then we can deal like that. This is the going on. There are two type of approaches in mathematical modeling, especially in cancer and tumor. This is the flow chart. This is the flow chart for the process. I don't want to take too much of time. Initially, we want to find the situation, then developing a model, then calibrate with the existing data and validate the data and evaluate the performance. And finally, we get the suggestion we give the practitioner. Based on the situation, sometimes we skip the step from the first step to last step, or first step to third step, like that. We may move based on the situation, based on our data, based on our mathematical model. Okay, now before going to the next one, can I play one video here for 2 minutes? You can see the video 1 minute. I can play one video. Now my screen is, I think you are visible. So can I play one video? Yes, I think you are see the video. What are all the types of cancer in India? They are explaining five different types of cancer in India. Then I can come to the slides. Already I'm in this flow chart. Then after that I will play the video. Now can I come to the presentation? Now hereafter I can show some of the very good paper in this field. From the paper I explain something. This is the one of the paper theory of hybrid dynamical system and its application to biological and medical system. This paper published in 2010. This paper will give the full detail about the mathematical modeling. You can open the paper also here. This is the open source, no need to pay. You can get it from Google search. I think now you see the paper, the title of the paper. Can I show you? Yeah. This is the theory of hybrid dynamical system and its application to the biological and medical system. This is a very good paper. In that paper, I want to mention one point in the conclusion part. Can I go to the conclusion part? That will give the detail why this much of paper. Yeah. Can I highlight it here? You see the screen. These article mainly categorize into three topics. Number one, biochemical and gene regularity networks. Number two, cancer and its treatment. Number three, neurons and neural system and neuromechanics. These three parts this paper will address in detail from starting to higher level. Here we can take the second part, cancer and its treatment with the help of. Can I show one differential equation they are developing here? Yes. Can you see this differential equation? There are dx by dt, dy by dt, and dz by dt. When I'm initially told about, when I initially told about, we may form the differential equation based on the situation. Sometimes we frame first order differential equation, sometimes we frame second order, sometimes we frame system of equation. Here you see the system of equation with the three unknowns and some other parameter also it is there. This is not a linear equation, this is a non-linear equation. This system would look like is simple, but it is not simple. Only the problem in this area of h of x. Can I show the h of x? What does mean by the h of x? Then you should understand. The h of x, the major part here. This is a non-linear differential equation. This is the way tell. This is the it cannot deal in simple manner. We cannot find a directly solution for this. Can you see here? The x, y, z are continuous state variable and alpha and beta are positive parameter. H of I is a piecewise smooth function of x. That is a major key role. One more function is there. We want to deal very careful. And I want to mention this is not developed by the tumor mathematical model. This differential equation not directly derived as a tumor case. This equation created by Chua, one scientist that is called Chua. The name of the scientist is Chua in chaos theory. What is mean by chaos theory? Then you should know there is one physics field chaos. What does mean by chaos? Can I explain simply? You can take a center point, then you can consider the radius of 0.00001 millimeter. You can make it a round as a radius, as a circle. Within a circle, fraction of time we can't say what it happens. That is called chaos theory. In that chaos theory, they are creating a model for the chaos theory situation. This model can relate to the mathematical tumor modeling. So already I told about there are two type of method is there. One is we develop the model, and second one somebody develop model. We correlate with the meaningful. This is the one very good example. This equation they created as a chaos theory, then it can be related to the tumor and cancer. This is the one important paper. If you want to enter into this field, we read this paper first, then we can get the clear picture about this area, clear picture about the field. Now I can come to the presentation again. Now, can I hereafter I can show some other papers also. then you should understand how so far this field is elaborate. These fields are developed. Now here I want to tell about another one important paper. That paper is fractals and chuas and cancer, do they coincide? There are three different words are there here. One is called fractals, second one chaos, third one cancer. All the three are different words, all the three are different field. All the field can connected. This paper will address the question, do they coincide or not? Yes, it is coincide, the paper will say. And I want to mention here, most probably when I show the paper, all the paper available in open source, no need to pay. But this paper available in paid version only. Can I open the paper? Yes. See that I can given the definition what is mean by the fractal and what does mean by the chaos. Then already I explained about what is mean by cancer. This paper will address all the three are coincide or not. As you know, it's a mathematical people, you may study in undergraduate or postgraduate about the fractal theory. The fractal is a type of the mathematical shape that are infinitely complex situation that will taking meaningful here. And chaos, already I told that within a closed boundary, we can't say what it means. And then cancer also, we don't know if the cell is muted, what it happen in the closed boundary. We can't say anything. These three technical field, they are connected. They will address this paper. Do they coincide or not? This paper will justify it. All these three are meaningful coincide. Now I can come to the next paper. Already I told about based on the mathematical modeling. Sometimes we may define as a one dimensional, sometimes we may define as a two dimensional, sometimes we may define as a three dimensional, multi-dimensional also. This paper, chaos in three dimensional cancel model. Can I open? This is the open source paper. No need to pay anything. We can get it from Google search. Yeah, this is the paper. No, this is not a paper. Can I show you? 1 minute. Can I take the paper here? Hyperlink is wrong. Yes, this is the paper chaos in three-dimensional mathematical model. This paper published in 2009 and no need to take too much of time. Here you see that there are three differential equations. This is a three-dimensional model. Then they are dealing with the meaningful. Then they will use the MATLAB and they will give the suggestions. Many things it's going on. Technically, they will deal the paper and detail. Then finally, they given the conclusions. So this is the one good paper in three-dimensional mathematical model. Now I can continue my presentation now. Then I tell about the hybrid approach to the multi-scale mathematical modeling. Already I told about the paper that is called one-dimensional model, two-dimensional model, and three-dimensional model, and hybrid model also. Sometimes some of the parameter are continuous, some of the parameter are discontinuity, and everything we mixing here, and then we call it as technically hybrid approach and multi-scale mathematical model. This is the another one paper will give the detail about the tumor mathematical modeling of multi-scale. And then I want to mention the next paper. Already I told about chaos theory and mathematical model. Both are can be connected. Then this paper will address the question how they connected. What can be learned from the chaotic model? Can I open the paper? That but best. Yes. You see the paper. What can be learned from the chaotic cancer model? How they will related that simple paper will address in detail meaningful. Now I can continue the next one. A mathematical modeling of tumor growth and treatment. As I know, as I tell earlier, when we given the math, when we construct the mathematical model for the treatment purpose, as we know, there are various methodology available for the cancer treatment. Sometimes the extra normal growth is removed. Sometimes they are given the medicine. Sometimes we given the radiation based on the situation of the extra normal growth. Our purpose is to find the mathematical normal growth, rate of growth, and given the suggestion to the medical practitioner. So the treatment is a very big vital role here. Simply mathematical model, and then we analyze, we give the solution. It is not useful one. It can be applicable in in medical field. So the treatment role will come. Can I show that paper here? Yeah, this is one dissertation. The number of pages is 24 in this paper. This is published. That paper they will address with a very simple differential equation. They will start with very small differential equation and then develop step by step, step by step. Finally, they are come to the conclusion which treatment is suitable for the situation. This is the another one best paper. So I can say these four paper, one, two, three, four, five papers here I mentioned here. We read these paper, then we understand what is the reality it is going on. And then already I told when we given the after the mathematical model, we want to given the proper guidance, proper advice, proper suggestion to the medical practitioner through the mathematical model in which therapy is suitable and which therapy is not suitable. Also, can we find out, can we given the suggestion based on the literature and based on our findings, everything we can done here. And before going to the next one, I can play another one video. They will deal this video. It will take 4 or 5 minutes. Can you listen carefully this video?
I am a translator. I translate from biology into mathematics, and vice versa. I write mathematical models, which in my case are systems of differential equations, to describe biological mechanisms, such as cell growth. Essentially, it works like this. First, I identify the key elements that I believe may be driving behavior over time of a particular mechanism. Then I formulate assumptions about how these elements interact with each other and with their environment. It looks something like this. Then I translate these assumptions into equations, which may look something like this. Finally, I analyze my equations and translate the results back into the language of biology. A key aspect of mathematical model is that we, as modelers, not think about what things are. We think about what they do. We think about relationships between individuals, whether they be cells, animals, or people, and how they interact with each other and with their environment. Let me give you an example. What do foxes and immune cells have in common? They're both predators, except foxes feed on rabbits and immune cells feed on invaders, such as cancer cells. But from a mathematical point of view, a qualitatively same system of predator-prey type equations will describe interactions between foxes and rabbits and cancer and immune cells. Predator-prey type systems have been studied extensively in scientific literature, describing interactions of two populations where survival of one depends on consuming the other. And these same equations provide a framework for understanding cancer-immune interactions, where cancer is the prey and the immune system is the predator. And the prey employs all sorts of tricks to prevent the predator from killing it, ranging from camouflaging itself to stealing the predator's food. This can have some very interesting implications. For example, despite enormous successes in the field of immunotherapy, there still remains somewhat limited efficacy when it comes to solid tumors. But if you think about it ecologically, both cancer and immune cells, the prey and the predator, require nutrients, such as glucose, to survive. If cancer cells outcompete the immune cells for shared nutrients in the tumor microenvironment, then the immune cells will physically not be able to do their job. This predator prey shared resource type model is something I've worked on in my own research, and it was recently shown experimentally that restoring the metabolic balance in the tumor microenvironment, that is, making sure immune cells get their food, can give them, the predators, back their edge in fighting cancer, the prey. This means that if you abstract a bit, you can think about cancer itself as an ecosystem where heterogeneous populations of cells compete and cooperate for space and nutrients, interact with predators, the immune system, migrate, metastases, all within the ecosystem of the human body. What do we know about most ecosystems from conservation biology? That one of the best ways to extinguish species is not to target them directly, but to target their environment. And so, once we have identified the key components of the tumor environment, we can propose hypotheses and simulate scenarios and therapeutic interventions, all in a completely safe and affordable way, aimed at targeting different components of the microenvironment in such a way as to kill the cancer without harming the host, such as me or you. And so, while the immediate goal of my research is to advance research and innovation and to reduce its cost, the real intent, of course, is to save lives. And that's what I try to do through mathematical modeling applied to biology, and in particular to the development of drugs. It's a field that until relatively recently has remained somewhat marginal, but it has matured, and there are now very well developed mathematical methods, a lot of pre-programmed tools, including free ones, and an ever-increasing amount of computational power available to us. The power and beauty of mathematical modeling lies in the fact that it makes you formalize in a very rigorous way what we think we know. We make assumptions, translate them into equations, run simulations, all to answer the question. In a world where my assumptions are true, what do I expect to see? It's a pretty simple conceptual framework. It's all about asking the right questions, but it can unleash numerous opportunities for testing biological hypotheses. If our predictions match our observations, great, we got it right. We can make further predictions by changing this or that aspect of the model. If, however, our predictions do not match our observations, that means that some of our assumptions are wrong, and so our understanding of the key mechanisms of underlying biology is still incomplete. Luckily, since this is a model, we control all the assumptions, so we can go through them one by one, identifying which one or ones are causing the discrepancy. And then we can fill this newly identified gap in knowledge using both experimental and theoretical approaches. Of course, an ecosystem is extremely complex, and trying to describe all the moving parts is not only very difficult, but also not very informative. There's also the issue of timescales, because some processes take place on a scale of seconds, some minutes, some days, months, and years. It may not always be possible to separate those out experimentally. And some things happen so quickly or so slowly that you may physically never be able to measure them. But as mathematicians, we have the power to zoom in on any subsystem in any time scale and simulate effects of interventions that take place in any time scale. Of course, this isn't the work of a modeler alone. It has to happen in close collaboration with biologists. And it does demand some capacity of translation on both sides. But starting with a theoretical formulation of a problem can unleash numerous opportunities for testing hypotheses and simulating scenarios and therapeutic interventions, all in a completely safe way. It can identify gaps in knowledge and logical inconsistencies and can help guide us as to where we should keep looking and where there may be a dead end. In other words, mathematical modeling can help us answer questions that directly affect people's health, that affect each person's health, actually, because mathematical modeling will be key to propelling personalized medicine. It all comes down to asking the right question and translating it to the right equation. And that. Thank you.
Yes. Now again I come to the my presentation. The researcher tell about uh, uh, she is from Germany. He is tell about how the mathematical model can connect to this field in simple words. What are all my I am telling the same thing. He will she also address the same issue with meaningful. When we construct the mathematical model at that time we consider about the environment. In environment mean what does it mean? There is a normal cell, an immune cell, and a tumor cell. All the three are it is available. When we deal the for example, can I tell about one simple example? If I'm doing the radiation in the right finger, at that time I want to kill the normal cell also. That's the peculiar the difficult chances are there in that treatment. So if you construct the meaningful mathematical model, then we can get into the area, then we'll do the meaningful output also. Here I want to mention three more papers here. This paper will addressing on the whole. When I start the presentation with the one paper, that paper is the introduction part I told. This is the full history you will be get it in different type of mathematical model also you will be get this paper. This paper will publish it in Nature. This is a open source paper. No need to pay to read this paper or download the paper. It is available in Google search engine. You will be get the paper. And that paper it is called the mathematics of cancer integrating quantitative models. Almost all the mathematical technique, what are all the models available, this paper will address. Can I show few things to you? First one, the branching and Moron process. Based on that, they will explain the tumor microenvironment. And then here you see what are all the microenvironment available, the normal cells, stem cells, what is happening in that one. That is everything will address the tumor microenvironment. Here some of the graphs also they are given. As you know, somebody you know very well about the graph theory and graph coloring and graph labeling. That concept also can applied here to address the situation. And then I want to here you see there are three or four technical words they are given: deterministic model, and everything they will address with the elementary to the higher level and with the proper references also. And then if you want to the higher level of information about the cancer mathematical model, we taken this paper and read uh, thoroughly and slowly. We'll get the full information. Can I show in some more? This is a differential equation and then partial differential equation, and many things will address meaningful due to the various cases, various situations. So this is the full information we will be get the paper from here. Now, can I continue my presentation, yeah, then I can show in the two or three papers. We are Indian. We proud to be Indian. When we talk about the research, then we want to know the reality, what happens in India, how it will useful. Then it is a benefit for our people. Usually, we are always working to save the community, save the society. So we want to looking about the India. We want to take and the reason development, what is going on in the perspective of the India. So this paper will address cancer research in India, challenges and opportunities. This is a survey paper. This paper will address what is going on here in cancer research about India. And then is another paper, cancer epidemiology literature from India. Does it reflect? These two paper also open source. We will be get the Google search engine, no need to pay anything. When we talk about the research, usually the research point of view, the people are telling think locally and act globally like that. So we want to think about our surrounding, those who are living near to us. We want to save the life. There is, there is a problem in the cancer in throughout the world, throughout the globe. Every country they have a separate division for the cancer, and then that cancer division supported by the various part, and mathematical gives a very big contribution to that part. Can I play one more video about the situation of our India? Wait a minute, that is a very short video, not lengthy more.
When a doctor says your child has cancer, it only means my child is dying. We want children in India to have exactly what any child who is faced with cancer anywhere in the developed country has. Why should they not?
I was 14 when I came to know I was affected with leukemia. When my doctors told me that you have leukemia, I was like, I don't want to undergo treatment. I just want to go home and have lots of food for the last time before I die. And they were like, see, listen to us carefully. You undergo the treatment, and we assure you, like, you'll live, you'll not die, because leukemia is one of the most curable cancers in the world.
We are currently researching appropriate therapy for a child with leukemia in India, and Professor Bhaskar Saha is leading that trial. Dr. Bhaskar Saha came back from UK to India to take up this challenge, to actually look at developing a standard of care protocol. With the training I received in the United Kingdom, experience at the University of Manchester, it kind of looked to me that I was the guy who should take this challenge up. And if I didn't take it up, then who was going to? He has catalyzed change for me. But the fact of the matter is that we have maybe 80,000 new cases of childhood cancer in the country. So what we need is protocols and standards where even the smaller centers can benefit. We talk about the living bridge between India and Britain, flow of people, ideas, technologies. And certainly this example, University of Manchester, working with the Tata Medical Centre, is one of the best examples I know of. ক্যান্সারের এই রিসার্চগুলো পরবর্তী দিনে আরো ভালো হয়ে যাবে, অনেক মানুষ আসবে যাবে, কিন্তু এখানে তাতে পরবর্তীকালে আমাদের যেমন এতটা সময় লাগে তাদের অত সময় লাগবে না। Universities like internationally ranked University of University of Manchester help the society. They're funded by society. You have to turn it back to society. This is a larger global society. And hope to the world to say that we have done this and we can benefit everybody.
Yes, can I come to the presentation again? Almost I complete my presentation and then I tell everything almost. Before winding the session, I want to tell about my research path here in this field. When I start my research in cancer mathematical model, I publish few papers. In our university, we have the facility for the cancer biotechnology, BTech cancer technology people. Especially there is a course for BTech cancer biotechnology. As you know about the biotechnology, and in particular, in specified more cancer biotechnology, it is there. The students are studying interestingly for the BTech course in cancer biotechnology. In that cancer biotechnology students, we may use as a mathematical people, we construct the model and then we validate the model using through the biology cancer lab by the undergraduate students. They use the simulating model and insert the data. Sometimes they develop the mice and inject the tumor growth to the mice and then evaluate that experimental part and supported by the undergraduate third year and final year students. From the results we can incorporate in our paper, then we can publish the we are not sure about it. We are fully fighting and we are fully getting the idea. We are still in the process, still is going on. We don't know clearly what it happens. There is uncertainty. It is there every time. The situation is changes every time. Everything is changes. So we are not saying accurately for this. And as you know, when we deal the numerical analysis, the vital role play for the error analysis unwanted data. We want to reduce the error size. That's as you know is a researcher. So we are working in that. We are continually the process is going on. One time again, I come to the very famous quote. One time, Albert Einstein says about the life. If you want a life as a bicycle, if you want to balance it, keep on moving If you stop the moving, you fall down. That answer given by the Einstein. Taking the same word, we are working, we are keep on moving. Our fight is going on up to our end of life. Then our followers, they will take care of our parts. They will carry for the next level, because we also taking from the intellectual people. We transfer to the next generation. They will take care. It is a continuous process. So I will wind up. This is that's my end of my presentation. This is the recorded version, so there is no chance to interact the question and session. But anyway, usually I will tell one question. Sir, people are asking, due to the mobile phone cancer is increases like that. The people saying this is true like that. Some students asking many presentation. Yes, it is true. When we are using without wire system anything, then automatically radiation will come. Nowadays we are using always without wire connection, mobile phone, everything we are using remotely. When we are connected, not only the system, we are connected to the satellite. So the radiation always it is there. The radiation is available near to our body. And one thing we want to understand, basically all human beings are living particles having the cancer cell inbuilt, but the cancer cell not muted stage. If it is a muted, then automatically extra normal growth will come. So try to avoid the wireless material. Many people, they are keeping the cell phone near to the pocket. No, no, please, when they are going for taking a bath, at the time only they leave the phone. Please keep your phone away. The radiation, it is there. In the market, they are saying that iPhone having the less radiation. Yes, it is true, but it is also radiation is there. So we want to careful about the normal people also. We cannot say, because what is the reason for cancer, they have the list of reasons, then finally they put comma, there is no full stop, the reasons are continuing. So we want to careful about that. With these words, I finish my presentation. I'm not sure that may be interesting to one, and simple words I can explain to my point of view. If you have any question, kindly noted my mail ID. You can send a mail. If possible, I can send the appropriate answer to you. Thank you, one and all. I can thank to the very good opportunity for Aiman Education Welfare Society and Aiman Arts and Science Women College principal, head of the department, and all other faculty members and my student friends, those who are listening with the proper silence. Thank you, one and all. You can include in your prayer for all our people, all our humanity. Thank you, one and all. Assalamu alaikum.